Welcome back, guys. We are going to be doing some more logic puzzles. So if you didn't see the first episode, this is an app called Brilliant, and they've got a 30-day free trial. So if you want to play along, you can download the app. And yeah, you can get it on Google Play Store, Apple Play Store, and just on an internet browser, which is what I'm on at the moment. So yeah, play along if you want. Okay. So these are all logic puzzles, carrying on from the last episode. So shuffles. Sometimes lots of options is a good thing, but it can also make problem solving harder. This lesson is focused on uncovering approaches to cut down your options and reveal the solution. More lying robots have run amok. Last night, they mislabeled the safes that contain the coins that theme park visitors receive as prizes. They seem to be creating a distraction from something. But what? It's up to Marv to undo the mischief before the park opens for the day. Okay. He doesn't have much time, so he wants to only open the minimum number of safes he needs to be sure of the correct labeling. Since the lying robots always lie, Marv knows every safe is labelled incorrectly. Okay. How many safes does he need to open to be sure of what's really inside? Right, okay. So if we open gold, it can't have gold in because they all lie. So it's going to have silver or copper. Then if it's got silver in, then we know this can't be silver because they all lie. So that's guaranteed to have copper. That's guaranteed to have silver. So one safe. Let's see if opening one safe is enough. Marv tries his luck. The gold safe actually holds silver. That's exactly what I just guessed. What do the other safes hold? So this can't be copper because they always lie. That has to be gold. Correct. Happy days. Let's take a deeper look at why opening just one safe was enough to determine the contents of all three safes. We know that the coins are not going to match the chest label, so it is helpful to think about what arrangements are impossible. In other words, you are going to think about the matching pairs of coins and chests. Yep. After we open the first safe, how many matching pairs of hidden coins and unopened safes will be left? One. Let's say the gold safe actually holds copper coins. When we start with three safes, no matter which safe we open and which coin we find, we'll always have one matching pair of a hidden coin in its unopened safe. Here, the matching pair is silver, and since all the safes are mislabeled, the silver safe must contain gold coins. Marv moves on to the next group of safes, where again, every safe has been labelled incorrectly. How many does he need to open to be sure of what's really inside each safe? So let's do the same thing we did last time. Open gold, we get silver. Right, okay. Okay. Right, so if we open gold and we get silver, we already know that this can't contain silver because it's lying. So this has to contain either jade or copper. So if we open, let's say we open this one. I don't know if it's the best thing to do. It might be better off to open one of these two. But let's say we open this one. We get jade. Right, let me think. So that would be silver, jade. I think I need pen and paper. I think this is so much easier with pen and paper. Right, let me just grab pen and paper. So we open the gold. We open the silver. We got silver. We got jade. Which means that the remaining boxes to open are copper and jade. The remaining coins to find are gold and copper. We know that copper must be lying, so we know what's in the last two safes. So just two. Let's give that a try. Okay, the first one you open actually contains jade. Okay, how many ways could the remaining coins be hidden in the safes? Remember, every safe has a false label. How many different possible arrangements are there? So the different possible arrangements, jade would have to be either silver or copper. Oh no, gold as well, sorry. Gold, silver and copper. Right. That could be gold or silver. Can't be jade and it can't be copper. That could be gold or copper. So 322. So 321, 312. Right, right. Let me grab pen. Right, so jade could be gold, silver, or copper. Copper can be silver or gold, and silver can be copper or gold. So if we start with jade, we could have gold, silver, copper. Then we could have silver, gold, copper. And we could have copper, silver, gold. So it's just three. I think I would have struggled a lot more without having pen and paper, but I think it's just three. Okay, with the gold safe actually holding jade coins, we can't yet be sure of which coins the other safes hold. Looks like Marv will need to open another safe. Does it matter which safe he opens though? Which safe should Marv open next? Right. Now if he opens silver, I think the answer should be jade, because jade has got three possible. Because it doesn't matter which is not an option, I think jade is going to be the correct option, because that will cancel out three possibilities where if we went for silver, I don't think it matters, does it? If we went for silver, right, let's say we went for silver and we got copper. Then jade and copper could contain silver or gold. And the same would apply if we went for copper. So yeah, jade is the correct answer. The jade safe actually has silver coins. Okay. So we know this one's lying. So that has to be the answer. Right, when figuring out the true contents of 4 mislabeled safes, the key step is choosing the right second safe to open. Yep. Which safe is the better choice? The safe matching the coin Marv just found. Yeah. After opening the first safe, there are only 2 matching pairs left. Which safe should Marv open to have the best chance of knowing what's in all 4 safes? This is exactly what we've just done, isn't it? That's right. So this is just explaining what we've just figured out, basically. If he opens the J safe, one scenario, find a silver. Yeah, we've just figured all this out. Thank you very much. So as soon as Marv opens the J safe, regardless of what it shows, he'd figure out what is in each of the 4 safes. Yeah. Okay. Marv is running out of time. He scurries over to the final group of 5 safes where, again, every safe has been labelled incorrectly. How many does he need to open to be sure of what's really inside each? Right, now I assume as soon as you have 2 safes left, you know the answer. Because when we had 3 safes, we had to open 1, which left us with 2. The last one was 4, we had to open 2, which left us with 2. So, rather than going to work it all out, I'm pretty damn sure, oops, sorry, we just need to open 3. Before Marv opens any of the safes, there are 5 matching pairs among the unopened safes and hidden coins. How many matching pairs will be left after Marv opens the first safe? 3, is it? Right, am I reading this properly? Well, we know they're all labelled incorrectly. So you're guaranteed to get one of the others in the gold. So if I open gold, I'm guaranteed to get one of the others, which would mean that it discounts 2 of them immediately, which means there's only 3 left. That's correct, isn't it? Yeah. Marv opens the gold safe and finds copper coins inside. He stops to think about which safe is best to open. Although there are 4 choices, there are really only 2 options. Open the safe that matches the coin, open a safe that doesn't match the coin. Well, we worked this out earlier. The best thing to do is open the safe that matches the coin. After Marv opens the copper safe, how many matching pairs of hidden coins and unopened safes are there? So it was 3. Right, so that's gold, copper, and something. Let's say it was silver. Right. I'm a bit confused on this one. The fact that it says 2 or 3 is throwing me off a little bit. Right, is it because he might get gold? And if he gets gold, there might be 3. Because I'd still have silver, jade, and topaz left. So I think 2 or 3 is the answer. Yeah, happy days. Nice. Opening the copper safe guarantees that there will be 2 or 3 matching pairs. Marv opens the copper safe and finds a topaz coin inside. This means that he has lost the topaz pair. He still has 2 matching pairs, silver and jade. Which safe is the best choice? So, topaz. Yep, Marv opened the topaz safe. Drag the correct coins to the remaining safes. So silver can't go in the silver because we know they're all lying. Okay, the lying robot's mischief has been undone, just in time for the park visitors. But Marv can't stop thinking about those safes. If there had been 6 mislabeled safes, how many would Marv need to open? So, if you have 3, you just need to open 1. So it's just 2 less. So if you had 6, you have to open 4. Okay, here's what Marv's learnt so far. To figure out the contents of 3 mislabeled safes, you need to open 1. Yep, 4, you need to open 2, yep. Okay. If there had been 12, you would need to open 10. Marv knows that he applies the right strategy. He's guaranteed to know the answer by the time he gets down to the last 2 safes. All he has to do then is subtract 2 from the total number of safes, and he knows how many he'd have to open. Okay, happy days. That wasn't too bad. I don't think I got one wrong. Might have done. I don't think I got one wrong there. So I'll quickly jump into the next one. Okay, next up, false information. Knowing what's not true can often be as useful as knowing what is. In this lesson, you will learn to deduce the truth from a combination of statements that are true and false. The skill will come in handy in the next lesson, where you'll learn a method for solving complex logic problems by eliminating impossible conditions. Okay, Marv has got to the roller coasters for his next shift and he's running late. Fastest way there is through the escape room. Marv enters the escape room and sees 2 doors with signs on them. In this room, one door is safe and the other is a trap. At least one of the signs is false. Okay. So, which door is safe, which is a trap? I've got complete brain freeze at the moment. Right, okay, come on, wake up. Which door is safe? Oh no. Internet's gone down. Right, bear with me. Right, we're back. Okay, so in this room, one door is safe and the other is a trap. At least one of the signs is false. So, let's say this is a trap and that is safe. This door is a trap, that's true. This door is not a trap, that's also true. So that can't be correct. This door is not a trap, that's false. This door is a trap, that's false. So you need 2 false. So it has to be this one, yeah. Happy days. What does it mean if the statement, this door is not a trap, is false? It means that the door is a trap. Double negation. Marv enters the next room and sees 2 buttons. One of the buttons leads to safety. The other one leads to a trap. The label on the blue button is false. It is untrue that this is not a trap. Okay, so it is true that this is a trap, but the label on the blue button is false. So it is true that this is a trap, which means that it isn't a trap. So it's blue. Oh, thank God for that. I had me second guessing myself then. That was a triple negation. Okay, in the next room, there are 3 doors with signs on them. In this room, there is only one door to the next room for escape, and it has a false sign on it. Oh my God, my brain is hurting already. Okay, the other 2 doors have true signs on them, so there's one that's lying and 2 that are true. Right, which door should Marv take to escape the room? So we need 1 lying and 2 true. So escape is behind door 2. Let's assume that is lying. Escape is behind door 3. Escape is not behind this door. So this one can't be the one that's lying. So let's assume this is the one that's lying. Why have I got that symbol over there? That's annoying. Escape is behind door 3, so let's assume that one is lying. Escape is not behind this door, so that'd be the truth. Escape is behind door 2. So lying, truth, truth, and then door 2 would be the escape. So let's see what would happen if we choose this one. So escape is not behind this door, so if that is false, then escape is behind this door. So that would mean this is true, but it would mean that is false, and we can't have 2 falses. So it has to be number 2. Happy days. Okay, compare the statements of the first 2 doors. Right, the first 2 doors, escape is behind door 2, escape is behind door 3. It is possible for both door 1 and door 2 to tell the truth. Oh, is it possible? No, clearly not. Marv escapes to the next room, where there are 2 more doors. In this room, only one of the doors is a trap. How many of the signs are false? Well, one of them's false. They can't both be false, and they can't neither be false. It's got to be one. Marv has reached the final room of the escape room, where he sees a door with 4 buttons. He must push them in the correct order to escape the room. To unlock this door, the square must be pushed before the star. So the square must be pushed before the star. The circle must be pushed before the triangle. There are 3 more clues, but only 2 of them are true. Oh my God, are you kidding me? So we've got to figure out which one of these 3 clues is lying. Oh my God, how am I meant to do this? Okay, let's see if we can work it out. The triangle must be pushed immediately before or after the star. Right. Well, that might not be true because in this scenario you don't need to. So let's assume that's false. Would the next two be true? The square is not pushed immediately before or after the triangle. That's true. The circle is pushed immediately before or after the square. That's not true. So that's two lies. So this can't be the correct order. So the circle must be pushed before the triangle. The square must be pushed before the star. So let's try this. The triangle must be pushed immediately before or after the star. Okay, so that one's true. The square is not pushed immediately before or after the triangle, so that's true. The circle is pushed immediately before or after the square. That's true. That's three truths. What? Right, so the square must be pushed before the star. So I can move that to there. So the triangle must be pushed immediately before or after the star. That's true. The square is not pushed immediately. The square is not pushed immediately before or after the triangle. That's true. The circle is pushed immediately before or after the square. Oh no. I feel like I've got three truths again. So am I allowed to put this here? The square must be pushed before the star. No, I can't. So what about if I put this here and that there? Square must be pushed before the star. The circle must be pushed before the triangle. Right, let's try this then. The triangle must be pushed immediately before or after the star. So that's false. The square is not pushed immediately. Oh my goodness me. Now I've got two falses. Oh my god. I've got three falses here. What have I done wrong here? Wow. This is a difficult one. This is by far the hardest one that we've encountered so far. Now let's put that there. So that's true, false, true. That's true, true, false. Right, I think it's this. Oh, I don't know how I messed that up the last time I checked this. Right, happy days, I did it. He's out, just in time to make it to his shift at the roller coasters. Wow, that was a toughie. That one was a toughie. Okay, I think I'll jump straight into the next one. Okay, next up we've got process of elimination. When comparing items, it can help to think in terms of extremes and contradictions. In this lesson, you'll learn strategies for efficiently identifying useful information even when you're starting from very little. Marv arrives for his shift at the roller coasters, where the maintenance team is conducting routine testing. He's tasked with recruiting the right robot testers for each ride. Each roller coaster has specific weight requirements, and some of the rides are too fast for older model robots to ride. They'll fall apart. Okay. Marv needs to sort the robot volunteers so that he can match them with the right ride, sorry. To do this, he'll have to piece together various bits of what he knows about their specs. For the first group, Marv knows that when the robots are lined up in order of model age, Nook and Norb are next to each other. Okay. Right, well, if Nook and Norb are next to each other... Sorry, it says which robot would be in the middle. Sorry, I forgot to read that bit out. So, if Nook and Norb are next to each other, Flo cannot be in the middle. So, Nook or Norb. Okay. Marv also knows a few additional facts about these robots. Here's everything he knows. When the robots are lined up in order by age, Nook is next to Norb, which means that Flo has to be either the oldest or the newest. So we can take off mid. Flo is heavier than the newest model robot. So does that mean she's the oldest and one of the heaviest? Because she can't be mid, and she's heavier than the newest, so she has to be the oldest. When the robots are lined up in order by age, Flo is next to Nook, so that means that Nook has to be the mid and Norb has to be the oldest. Happy days. The next set of volunteers lines up. Marv knows these. The lightest robot is newer than Ray. So Ray can't be the lightest, and he can't be the newest. The heaviest robot is newer than Lex, so Lex can't be the heaviest, and he can't be the newest. Loy is not the heaviest. Okay. So that means that Ray has to be the heaviest. Okay. So that means that Loy has to be the newest. So the heaviest robot is newer than Lex. Okay, so we've got the age. The lightest robot is newer than Ray. Which means that Loy is the lightest. So that means Lex is the middle. Happy days. Okay, you can just deduce the right answer by eliminating the extremes. In the next group of volunteers, Marv knows these. There are two sets of two robots that share the same model age. Okay. When the robots line up in order by weight, their model ages alternate between new and old. Okay. So it either goes new, old, or old, new, old, new. Okay. Ty is one of the newer model robots. Okay, so we can take old off. So it looks like we've got new and old, and then we've got the 4 different weight classes. Zat is heavier than Dex. So Dex can't be the heaviest. Ada is heavier than both the older model robots. So does that mean that Ada is one of the new ones? I think it does. So these would be the older ones. she is heavier than these two, which means she's either third or fourth. The older ones are first and second. No, no, no. Shouldn't have done that. Because it's possible that she is fourth and then third. Yeah, okay, okay. Right, let's start from the beginning again. So they alternate in age by weight. So if Ada is the heaviest, then Ty would have to be the second. If Ada is third, then Ty would have to be the lightest. There's nothing here to help with that, I don't think. When the robots are lined up in order of weight, the model ages. Right, well, he can't be light. So it's possible. Right, these are old, so it can't have first and second, so it'd have to be first and third. Or second and fourth. Right. Right, so if Ada is third and fourth, that means that Ty has to be first or second. But I don't really know how we're going to figure this out. That. Ah, I've accidentally checked this when I shouldn't have done. So that should be the answer. It's because when I made a mistake earlier, I forgot to uncheck. Or I accidentally rechecked something that I shouldn't have done. Okay, sorted. For the next group of three, we know these. var is not the heaviest. Okay, so var not the heaviest. When the robots line up in order of model age, var and ig are not next to each other. So that means that ig has to be the heaviest, which means that var has to be the lightest, which means Jan has to be the middle one. The heaviest robot is newer than the medium weight robot. Oh, wait a second. Have I messed this up? Let's start again. Start again. var is not the heaviest. When robots are lined up in model age, var and ig are not next to each other. So I'm guessing it goes from new to old. So that means that var and ig cannot be mid, which means that Jan is mid. Yeah, there we go. Sorted. So the heaviest robot is newer than the medium weight robot. So he can't be the heaviest. In a min. Yeah, than the medium. In a min, what am I doing here? Come on, come on, my brain is not working. The heaviest robot is newer than the medium weight robot. I don't think we can identify that yet. The lightest robot is newer than IG. Well, if IG can only be new or old, he can't be new, which means he can't be old, which means the heaviest robot is newer than the medium weight robot. What? Right. So these two, one of these two has to be heavy, and the heaviest one is newer than the medium. Which means that Jan has to be the heaviest. There we go. Var is not the heaviest. Right. Have I messed something up here? The lightest robot is newer than IG. Which means Var has to be the lightest. Which means IG has to be the medium. Happy days, happy days. Took a few attempts, but got there in the end. Right, Marv isn't familiar with the next group of robots, so he has to rely on the clues these robots give him to rank them. However, he receives a note from the robotics division that one of the robots in the group is malfunctioning. Oh god, I hate these. I'm really not good at these false information questions. Okay, one of their statements below is false. Right. Okay, one of the statements below is false, but Marv doesn't know which. MiG is the oldest model robot. When the robots line up in order by weight, the two newest model robots are next to each other. MiG is the heaviest robot. GOM is older than the heaviest robot. Right, okay, so GOM is older than the heaviest. This says MiG is the oldest and the heaviest, so one of these statements is a lie. So that means that statement 2 and 5 are definitely true. So if 5 is definitely true, then that means that 3 is the lie. So at least we've identified the lying one anyway. So that one is the lie. MiG is the oldest. GOM is older than the heaviest, which means Jet is the newest and the heaviest. When the robots are lined up in order by weight, the two newest models are next to each other. So, the two newest by weight. Yep, I think that's right. Happy days. Okay, let's take another look at the clues. Scan for contradictions. Yep. I got all of them. Happy days. Marv has never met the final group of volunteers either, but he's happy that they're here and willing to help. Again, he's warned by the robotics division that one robot in the group is giving false information. Right. Exactly one of their clues is false, but Marv doesn't know which. When the robots line up in order by weight, the two older model robots are not next to each other. Ash is older than the lightest. Jank is older than the heaviest. Zod is older. Well, we can't have three that are older because we've only got three. So one of these three is lying. So Jank is the medium weight robot, so we know that is a fact. When the robots line up in order by weight, the two older model robots are not next to each other. Right, come on, brain. When the robots line up in order by weight, the two older model robots are not next to. So the two older ones, so the newest one is in the middle. So we know that Jank is the newest and the middle. Right, so we know then that this is the lie, because Jank is the newest, so he can't be older. So that one's the lie. Ash is older than the lightest, so Ash has to be the heaviest and older. Right, yep, I'm pretty sure that is correct. Happy days. Another job well done. The volunteers have been sorted and Marv will be able to safely test all of the roller coasters. Happy days. Right, I think that will do for this video. Hope you've enjoyed the puzzles. Let me know if you want to see some more. Right, cheers for watching. Take care. I shall see you soon.